Okay, so good day to all who will be watching this video. And again, this is my video presentation in my outcomes evaluation in electromagnetics. So the title of this, sorry. So the title of this, uh, the topic that we are talking about here in electromagnetics now is dielectric. So by the way, I am Merard A. Lucero, a BSEC student of LPU Laguna, and now we'll go with this dielectric topics. So what is the objective of this? So first, it is to define what is electromagnetic, what is dielectric, and identify the different types of dielectric and polarization methods in dielectric and properties of dielectric and its application. So first, we have to define what is dielectric. So by definition, it is materials, it is our materials that don't allow current to flow. So it is also often called as insulator because it has poor electrical conductivity and materials that can be used to store electric charge or to increase capacitance. Okay, so in summary of this, we can we can call this dielectric as insulator, which has the property of full electrical conductivity and don't allow current to flow easily. So these are what is dielectric. So how is dielectric works? So I have here a schematic diagram of how dielectric is wired. So we have here on the bottom is a power supply, either DC or AC. So DC is direct and AC is the alternating current. Okay, so by the power source, either AC or DC, there are two wires that are connected with two metal plates. So basically, this is the part where the power supply is flows. Then at the center of that is the dielectric, either solid, liquid, and gaseous. Okay, so I'll show you the initial state of atoms within the dielectric. So as you can see in this image, the atoms are moving freely or no no uh, no systematic orientation that it has. So upon having the supply or when the dielectric is energized, this becomes the image of that. So apparently we have this side as the positive side and this one is the negative side. So the positive side is where the electron, so we can call this as positively charged because the electrons in this part is lower than the other part. So this one, this part is negatively charged because it has higher electrons than this opposite side. Okay, so upon the energization of this dielectric, so since this is a positive side, all the negative uh, particles goes through it or attracts through it. Same goes with this part. So this is negative, so that is the reason why this positive charge, a positive atom approach to this side. Then this becomes negative positive, negative positive because of this side is positive, then it attracts the negative part of this atom. So this basically the image, the microscopic image of the atoms within the dielectric. So if you can see it, I have here a more detailed image of that. So apparently, this is a polarized molecule because it follows the same concept of the opposite attracts. So that is why it image more connected atoms of this dielectric. Okay, so what are the types of the dielectrics? So I have here a diagram. So solid, there are three types mainly: the solid dielectrics, liquid dielectrics, and the gaseous dielectrics. So these are all the examples of these dielectrics. So also I have here more detailed image: the ceramic insulator as part of solid, the liquid just like this one, and the gaseous, which is apparently also a gaseous material. So let's go deeper with that, with the meaning of that. So what is solid dielectrics are? So by meanings, solid and used in capacitors. So mainly the application of this solid dielectrics is used in capacitors. Next one is the liquid dielectrics. So in liquid state, to prevent quick electrical discharge. So electrical insulators to suppress corona and arcing and serve as coolant. So this basically also serve as the coolant for the um, material. So this dielectrics is really essential. The next one is the gaseous dielectric. It can be used as an electrical material to prevent rapidly quench electric discharge. So what is the meaning of this rapidly quench electric discharge? So it is rapid. It means very quick, and electric discharge is it is also used. The gaseous dielectric is also used in high voltages like air capacitors, transformers, and circuit breakers. So we all knew that transformers and breakers are used in handling high voltages. So typically this is really dangerous. So that's the reason why we are using gaseous dielectrics on that materials, because this has the capacity to prevent rapidly quench of electrical discharge. Okay, so these are the three types of dielectrics. Next. So what are the polarization methods in dielectrics? So apparently we have three methods. These are the electronic polarization, the ionic polarization, and the orientational polarization. So let's go deeper with that. So what is electronic polarization? It is also called as the atomic polarization. It is happen when an electric field will always displace the center of the charge of the electrons with respect to the nucleus, and thus induce a dipole moment. So the image below shows what is the electronic polarization looks like. Okay, next. The ionic polarization. So ionic polarization has the material that should have some ionic character. So what is this ionic character means? So what particle the ions particle is brittle when it's solids, and it is also a good insulators in solid form but become good conductors in a liquid or dissolved form. So when it is in solid, it is a good insulator. Then when it melts into liquid or in gas in or dissolved in liquid form, this becomes a good conductor. So this is what the characteristics of ions. It also have high melting and boiling point compared to molecular compounds. So this is uh, some sort of characteristic of ionic polarization. So the material that undergo through this process would basically that have characteristic. Okay, so ionic polarization automatically has internal dipoles, but these built-in dipoles exactly cancel each other and unable to rotate. Okay, then next is the external field that induces net dipoles by displacing ions from their rest position. Then lastly, materials are all simple ionic crystal like NaCl. So what is this NaCl? So NaCl is also called as the sodium chloride or salt. Next, the third one is the orientational polarization. So we have also here the image of without field and with field of this, how this orientational polarization happens. So first, usually liquid or gaseous material. So anything that is liquid and gaseous material of these dielectrics happening with this orientational polarization. It must have natural dipoles which can rotate freely. So this is also the characteristic of uh, liquid and gaseous materials dielectric, because it can rotate freely. So I'm sorry. So this if solid, this can never be happen, because in solid materials the atoms cannot rotate freely because it is firm and close to each other. Also, the orientation of polarization in thermal equilibrium, dipoles will be randomly oriented and thus carry no net polarization. The external fields align these dipoles to some extent and thus induces a polarization of the material. So example of this is H2O in its liquid form. So this, because it is in liquid forms, orientational polarization happens. Then this differs when it becomes in its solid form or ice. Okay, next. What are the properties of dielectrics? So there are so many properties of dielectrics. So this is the good properties of a dielectrics are. Okay, so should have high resistivity to reduce leakage current. So what does this mean? So the inverse of the high resistivity is the good electrical conductivity. So this is the opposite of that. So the higher resistivity, the more its capability to reduce the flow of electric electric flow to it. Okay, so it should have high resistivity. Next, dielectric should have high dielectric strength. So what is the dielectric strength? It is the capability or the max voltage required to produce dielectric breakdown. The next, it should have also high mechanical strength. High mechanical strength provides the ability to withstand strength, to withstand strength of physical forces. So it is really important that a dielectric should have a mechanical strength. Next one is it should have high fire resistance. So it is to prevent the or restart passage of excessive heat. So that is why it is fire resistant. Also, it should have low thermal expansion. So what is thermal expansion means? It is the tendency to change the shape, area, volume, and density of the material. So it is really important that it has low thermal expansion. Next one is should have high thermal conductivity. So basically, this is also the same with the higher fire resistance. Yes, the higher fire resistance, because it is the transport of heat energy across a gradient. So what is that is the thermal conductivity. Okay. Next, should have low dielectric loss. So what is dielectric loss? It is quantified as the inherent dissipation of electromagnetic energy. Or this can also clarify or can be example as energy or heat. Next, it should have low water absorption quality. So this is not this is can be explained by words, but it is really important that the dielectric material doesn't have the capability to absorb water more, because it is important to maintain the quality of the dielectric product or material. Next, what are the applications of dielectric? So mainly, it is used in capacitor as the charge storage mainly between the metallic plates. So this also prevents the plates from coming in direct contact. So we all knew that what is the purpose of the capacitors are. So this is basically to serve as the reservoir, or it has the charge storage within the circuit. So this is the dielectrics is a main component of that capacitors. Okay, so this is the image of the capacitors, examples of capacitors. Next, it is used in the dielectric resonator antenna for producing and receiving microwave signals. So we all knew what is the image of antenna are. So this is this dielectrics is a part or main functioning part of antennas. Next, mineral oil is used as a dielectric and as a cooling material in transformer. We all knew that, so I have said this before. So liquid dielectric in liquid form. So this mineral oil serves as a cooling material for transformers, where we all knew that carries very high electric currents. Then lastly, it is used as insulator coating for wires and conducting materials. So this image here, an image of coaxial cable. So we have here the center conductor. So this transmit the signals and the electric. Then we have here the dielectric to um, to to contain that and that the flow of the energy in that. Okay, so this is the dielectrics. Next, so since you all knew that the dielectric is a main component of capacitors, so I have here the dielectric capacitors purpose. So we have here a three item. So first is to keep conducting plates from coming in contact to allow smaller plate corporations and therefore higher capacitance. So okay, so the dielectrics uh, is a really important part of capacitors. Next is to increase the effective capacitance by reducing the electric field strength, which means you get the same charge at a lower voltage. So same charge at a lower voltage. Next is to reduce the possibility of shorting out by sparking, more formally known as the dielectric breakdown during operation at high voltage. So these we all knew that dielectrics is really an efficient and effective part of what capacitors are. Next, lastly, so since we are talking about this dielectrics as it values in capacitors, so this image of capacitor here, and just a trivia, we have two normal usage of this capacitor. So this is a parallel capacitor, so the plates are parallel. Then this one is the rolled type. So basically the plates and the insulator is in the middle of this and rolled. So basically these two forms are just like this one. So hopefully you all knew you okay. So that is the end of my presentation in dielectrics. So I hope that you have learned a lot with this video presentation. And thank you very much for watching. I hope you are all doing good now and just stay at home and keep safe everyone. Thank you. Maraming salamat.